In this Cloud RF video, I'm going to be simulating a WISP node in Jonesboro, Arkansas. We've recently updated over 1,000 cities in the US with high-resolution LiDAR for your calculations in Cloud RF. The settings I'm using for this calculation are a mast height of 50 meters, a frequency of 5.2 GHz, RF power of 1 watt. In regards to antennas, I'm using 3 Tarana antennas which are from our antenna database. To set them up as 3 antennas, I've placed them at 0, 120, and 240 degrees, all separated by commas. In regards to the model, I've chosen the general purpose model, which is suitable for VHF, UHF, and SHF frequencies. I've also turned the diffraction to be off, so line of sight. This will help us to eliminate trees from the analysis, only taking account for buildings. Within the environment settings, I'm going to select the surface DSM profile for elevation. This uses the high-resolution LiDAR. I'm also going to ensure that line cover and buildings are turned off. For the output, I'm choosing a resolution of 5 meters, the LTE killer schema, a radius of 15 kilometers. I'm also using the GPU for increased performance. By running the calculation, I can clearly see the 3 antennas coverage across the city. I will now use the coverage analysis tool to check the line of sight to multiple properties from a single calculation. This can be done by pressing the import button and then selecting the coverage analysis. In this example, I'm using a CSV file with more than 400 points. These represent different addresses in the area. I've arranged these by latitude, longitude, ID, and group. We can now see that all the points from our CSV file have been uploaded onto the map. All of these points are covered according to the RSSI at that location. This is a very strong feature to say that we've only done one calculation to test the coverage at more than 400 locations. We can also see the coverage metrics table, giving us a breakdown of the coverage by group, which can quickly help us identify areas with weak coverage. To conduct further analysis into individual points, we can use the Path Profile tool located on the top toolbar. During the setup of this calculation and setting diffraction to line of sight, we've managed to eliminate trees from the analysis. Things like properties and other buildings are now the major obstacle, and this can be seen in the Path Profile tool as it has blocked coverage to this property. If required, we can also export our coverage analysis results as a metrics report. This metrics report will contain all of the points used for the coverage analysis, along with the RSSI of each individual point. A point to note is that these coverage scores will be given according to the colour scheme you've used. For more information on Cloud RF, please feel free to visit our website and try out a free demo. To stay up to date with the latest features and tools in Cloud RF, please subscribe to this channel.